Bienvenue à la conférence.
Excusez-moi, il ne parle pas français. J'ai besoin de traducteur.
International translator, engage. Let's begin again. Welcome to the 21-21 4R Fair. My name is Andrea Warren, and we are here today to present to you our city, Ville-Sauve, and its waste management system, Subterra.
Hi, my name is Kai-Louette Zurons, and I helped design the lovely futuristic architecture in Ville-Sauve, along with my fellow artists extraordinaire.
My name is Alice Belland. Our beta-level city with 600,000 Swavians has many tranquil rivers and beautiful rolling hills. We solve problems using advanced technologies, including smart life bracelets, holographic education systems, and safety drones.
Our smart life bracelets help us translate language, like we are doing here today, monitor our health, and communicate wirelessly with doctors and emergency services. How does this work? Well, electrical impulses travel wirelessly from bracelet to relay to brain.
Our holographic education system allows for an effective education that adapts to each individual's needs. It is used in combination with our bracelets that stimulate learning centers in our brain, and is proven technology that has skyrocketed us to the #1 education system in the world.
We have safety drones throughout our city that monitor traffic flow and emergency situations. Drones communicate wirelessly with the transportation hub to reroute traffic as needed. Also, drones give real-time data to first responders as they are traveling to emergencies.
Our airport, which is located above the city, has solar-powered airplanes with self-healing nanomaterials for structural integrity. However, life in Ville-Sauve hasn't always been this advanced. Waste management had reached critical mass by the year 2021. Luckily, Swavians found a solution. It's called Perde Pas, Bullet Pas, or Waste Not Whatnot. It has 3 main components.
The first is our Subterra Education Program, or STEP. It is accomplished through school education and public relations programs. For example, elementary students visit Subterra and Windtree Park to learn about the technologies used there. Middle school students enter the Future City competition to explore innovative technologies like our Subterra waste management system. High schoolers are then visited by engineers from Subterra to talk about the 4 R's and careers in engineering.
Artists like us participate in this festival, the 4R Fair, featuring local artists who use recycled materials to create applied and fine arts, such as this.
And this.
And this.
They are perfecto and only 100 euros each. Any offers?
Andre!
In addition to the 4R Fair, we have a wonderful time at our other yearly festival, the Sauve Swap, where families bring their unwanted items to be reused by others.
The second part of Waste Not Whatnot is called Intelli Home. This type of smart house technology reduces food waste to almost zero. The smart sensors linked to the smart system keep track of expiration dates of consumables in the pantry, thereby allowing use of the ingredients before they spoil. Trash is placed in containers that, when full, are loaded into the pneumatic system to transport to Subterra. Each home has its own composting system. Solar-powered robotic helpers collect food waste and yard waste, which is rich in nutrients, and spread the composted material across all the lawns.
And the third part of our solution is called Subterra. This is powered by the energy trees in Wind Willow Park and that line the streets. The trees incorporate wind and solar energy on the limbs. This helps to make sure Subterra is completely energy efficient. Pneumatic tubes bring waste from collection points and homes to Subterra, the underground waste complex. Here it gets sorted. Hyperspectral imaging identifies types of waste using magnetics, light, and thermal properties. Robotic drones use imaging information and visual recognition software to classify and separate waste.
Each type of waste is then distributed to separate processing pods. Each pod uses robotics to handle the waste as it is turned into raw or finished products. E-waste is further separated and sent to the appropriate pod. Some of its components, like resistors and capacitors, are salvaged for reuse. Hazardous waste, such as light bulbs, paint, and medicine, are incinerated at extremely high temperatures to break them down into their constituent elements. Elements such as gold, aluminum, and silver are salvaged and sold to labs and research facilities.
That's right, Andre. And the metal pod separates metal and turns it into sheets, bars, or wire. The paper pod recycles paper and turns it into new products. Glass and plastic are either cleaned for reuse or melted and turned into new products, such as bricks, flooring, deck material, and bottles.
Oh, but we can't forget. We credit the many engineers involved for making our city one of the leading innovators in waste management. For example, design and architectural engineers created schematics of the systems. Electrical and computer engineers designed the control systems for collection, separation, distribution, and processing. But all of our engineers use the design process to generate solutions to our waste management issue.
Step 1 defines the problem. 5 million kilograms of waste produced daily around the world. The next step was to learn the specs. They researched clean, efficient ways to reduce, reuse, recycle, and rot the waste produced.
They also had to research the risks and benefits. Some of the risks include mechanical, robotic, and computer control malfunctions. That's why Subterra has triple redundancy, which makes the system 99.92% reliable. In the case of normal wear and natural disasters, structural integrity is managed by self-healing nanomaterials.
To eliminate pollution, nanofiltration is used throughout the complex. Oh, and we also had to think about trade-offs. The initial cost of Subterra was high, but the cost is offset as products are sold for profit and by generation of electricity.
Also, robotics replace many human jobs, but as a result, many engineering jobs are created.
Then city planners, scientists, contractors, and investors brainstorm for solutions. Then they are ready to design the underground complex, robotic systems, and delivery tubes. Finally, tests were conducted and improvements were made. And now we are sharing it with the world.
But don't forget my art, isn't it magnifique? Any offers will be accepted and very appreciated. I would also like to offer this city model, which is 99.9% recycled. Any offers?
And that concludes our presentation. Merci beaucoup.
Au revoir.
Whatever.
What parts of your city rely on traditional technology, and what parts rely on new and innovative engineered future technology?
Well, our roads are almost exactly the same, except for we have grooves in our roads so that we have more, so there's more traction on the roads. This reduces a lot of accident and really helps make our city safer. But that is actually a technology that is used today.
And many of our commercial buildings rely on just normal technology that we have right now, but most of our residential homes have a new integrated system called Intelli Home.
As you put all these different things together, I'm curious, what was the biggest challenge that you felt you had to solve in terms of trying to make a clean, energy efficient city? What was your biggest challenge trying to solve it as you built your model?
I think the biggest challenge was trying to figure out how Subterra, our waste management system, would work and figuring out how we would power it.
Because like a system that large needs a lot of things to power it. So we kind of had to think of what's the most green, like zero carbon footprint energy that we could use to power all of Subterra. So we used wind and solar.
So of all the technologies that you talked about that make your city work, which one do you think is probably the most out there, or the one that might take the most time to realize?
Probably Intelli Home, because it's really new, but it's also really great because of how efficient it is, and it helps create our city, which is really reduces a lot of waste by 90%.
So in my opinion, I think that the Smart Life bracelets, well actually the relays, are actually the most futuristic, out there thing, because they actually stimulate the learning centers in their brain using electrical pulses. So I really think we could get there. We can, but not yet.
What do you think would be the downsize of the electrical impulses to the brain?
Little.
Small?
Yes.
Very small.
Very small.
Okay.
What's the most innovative aspect of your waste management system in the city?
Well, so in our waste management system, we have robotic drones that classify and separate the waste, so I think that's the most innovative.
And they use artificial intelligence too, so.
They can communicate to each other.
And that they can learn from if they put two chemicals that don't go together, something happens, then they can communicate to the other drones and tell them not to do it. And so nothing happens again.
So they're learning drones?
Yes.
There was a movie called Terminator that talked about that.
So you have solar power and you have wind power, and then you have connected in your park, and then you have the solar globes. And I think, did I cover all of your sources of power, or did I miss one?
No.
We also have biothermal, geothermal, and hydroelectricity.
And where is that, how is that used? Where and how is it used?
Well,
The
for
geothermal electricity.
the geothermal, okay, Isabel.
Okay, so for biothermal especially, that's used a lot on our farms because we take the cow pies and we harvest the methane and we burn the methane and we used it as electricity. We can also do this in our waste management facility. All the chemicals, all the gases released from the waste, we can harvest those and burn them and use them for electricity.
And why would people choose to live in your city?
Because we really make it important that we want our citizens to be safe, but we also want them to learn as much as they can about helping reduce the amount of waste. So we take that into factor with our Intelli Home, Smart Life bracelets. Everywhere around you is just lots of education.
I think another reason is probably because, well, you know, our city is so green and tree-y and forested. And so I really think that just because it's such a beautiful place that I really think that our citizens would love living there.
And our city is really accessible to everyone. Anyone could live in our city, like disabled people.
Mm-hmm.
We have ramps everywhere in the homes, businesses, and we have areas that people can go.
What are the major moving parts of your model?
So one of the moving parts of our model is the cantilever right here, which allows you to see subterra. And then we have the subterra system where it rotates the pods to separate the waste. And
then we have the airplane.
It's a Boeing, right? That's a tough question there.